Hi everybody, we are going to do a very brief density lab and I will help you take the data. So here I've got 4 steel spheres. They're carbon steel. They're actually bicycle bearings. I order them off the internet for my physics needs, carbon steel. And I know what the diameters are. They're printed right on the bag. So the largest one is a 1-inch ball bearing, then 3/4 of an inch, 1/2 inch, and 1/4 inch. Now in science, we don't use English, we use metric, so we're going to change from inches to centimeters, 2.54 centimeters, which is 0.0254 meters. Now, because these are spherical, the diameter is all you need to determine the volume, and I'm going to leave that up to you. Now, to determine density, you're going to make a graph to determine density. That's the purpose of this lab. We need the mass. So I have a couple of devices here. One of them is our good old balance, electronic balance, and I'll put the largest ball bearing there, and it's got a mass of 67 grams. And then now we've got the 3/4 ball bearing, 29 grams. The 1-inch ball bearing, 8 grams, pardon me. 1/2 inch, 8 grams. And then our smallest ball bearing is coming out at 1 gram. I'm not sure about that, so I'm actually going to turn to my really old friend, the triple beam balance. And I have this already tared or zeroed. I'm gonna put this, it's zeroed for the red cap, so my ball doesn't, pretty close there. We're gonna call that close enough. And now what I'm gonna do is I'm going to drop the ball bearing. There's the ball bearing. And so remember now that we were at about 5.5 grams, and now I'm going to see how much this ball bearing is. Oh, I went too far. A lot of practice, everybody. Ooh. So it is indeed about a gram. Let's see. I went from 5.5 to 6.5. So it's right about this little 1/4 inch ball bearing is just about 1 gram. Okay, so again, I would like you to make a graph of mass versus, ooh, I went in the wrong order. Mass versus volume, mass on the Y, volume on the X, and tell me the density of these ball bearings.